Hi, my name is Bill Wilkinson of DataMine Software, and in this video we will investigate how to calculate geologic model residuals in MineScape and analyze the results. Residuals quantify the impact of each hole on geologic model attributes such as interval thickness or floor elevation. Residuals are calculated by evaluating the difference of the model attributes when each hole in turn is removed from the model against when each hole is included in the model. The model is a good estimator of data when the residual is 0 or near 0. Analyzing the residual values can guide the user in selecting a model interpolator and help guide new exploration drilling plans. The analysis of the residual values will include generating histograms for the residuals, contouring the residuals, and contouring the interval roof and floor thickness for each model. MineScape Stratmodel provides 4 separate interpolators for geologic modeling. They are inverse, which is inverse distance to a power, planar, which is a triangulation interpolator with extrapolation, height, which is a MineScape interpolator, which is a combination of inverse distance and trend, and FEM, a finite element method for Stratmodel. MineScape help provides some guidance into which interpolators to use for thickness, surface, and trend. However, in our example and in our study, we will use all these interpolators for each of these separate areas. The steps to calculate and analyze residuals in MineScape Stratmodel is as follows. Step 1, create the 4 geologic models using each of the 4 interpolators. Calculate residuals for the 4 models. Generate histograms of the residual values. Contour the residual values for interval thickness and surface elevations, and then compare the results. Now we will create our 4 geologic models using our 4 templates. So we have 4 here. We're going to use one FEM, and the default is set to FEM interpolator for all of the thickness, surface, and trend options. I have another schema set up for height, and it has all of the height interpolators set for each of the components. I have one for inverse distance, and it's using inverse distance power of 2. And I have another one for planar, set planar to each of the thickness, surface, and trend. Each one of these schemas will output a different table file, grid file, so I can use those to select from when I'm doing my analysis. So I got that all set up. Now we will generate the 4 models. So geology table, I'm going to pick FEM, my drill holes are there, my layers are there, do an optional report file, do all the modeling steps. I'm going to do apply, and while that's running, I'm going to do height, apply, and while that's running, I'm going to do inverse distance, apply, and while that's running, planar. So that has generated me 4 geologic models using the 4 different interpolators for each of the components, thickness, surface, and trend. Well, now that we have our 4 models built, let's go do some residuals. And here in this form, we will specify our schema and what intervals we want to perform this calculation on. I'm just going to choose all of them. And what interval attributes we're going to look at. So I'm going to look at thickness, and I'm going to look at floor, and then we're going to output this to a table file. So we'll call this FEM residual. And I'm going to uncheck that. I want to see all the holes, whether it has impact or not. And apply. And there's one for that. FEM. Now I'm going to go to height. Just simply change out the table name. Apply. Let's go to inverse distance. that out. V, apply, and then also planar. So planar table, and apply to that. So now we have our residuals calculated for each of the 4 interpolators we used in the model. Okay, now that we have our residual tables created, let's go look at them. So we'll find those under our tables folder. And we've got a few here. Let's go to the FEM residual. And let's open that up. And let's have a look here what our table looks like. So for every hole, we have a collar X, a collar Y, and a collar elevation. And then for each interval, we have a attribute, upper A thick I for the drill hole is included in the model, upper A thick X for the value when the drill hole is excluded from the model, and an upper A thick D for what the difference is between the two. In our example, we're going to maybe go over here and look at the tough M thick in this first example. We have a series of columns for that. So let's have a look at a histogram of this information. So we go and grab a histogram. And let's look at the tough thick D column. We'll use 5 bins. And here we see the histogram for the tough M thick difference. The average is 0.1 meters in this case. The median is 0.08. The minimum is minus 0.24 meters, and the maximum is 0.48 meters. And then there's the quartiles, the variance of 0.02, the standard deviation of 0.13. So that's what we kind of come up with the FEM interpolator. Let's look at height. Here's our height table. Let's look at this as well. Let's grab a histogram of this. Again, we're going to look at the tough M thick D. Apply that, and here we have a little bit different result. We got an average of 0.05 with a median of 0.04, minimum minus 0.4, maximum 0.5, variance 0.02, standard deviation 0.3. So a little bit different result, and certainly a little bit different histogram. This is a nice even bell curve histogram. Let's have a look at the other ones. We had inverse distance. Let's see what that looks like. Open up the histogram for that. And thick D, apply. So yeah, a little bit different here as well. We got an average of 0.1, median 0.08, minimum 0.24, maximum 0.48. So these aren't looking too bad either. A little bit different look on the histogram. And then finally we had planar. So let's look at planar and look at the histogram for that. So looking again at tough M thick D, and apply that. And here we got yet again a little bit different result. Average 0.11, median 0.09, minimum maximum, upper lower quartile, and so on. So this is how you can have a look at some histograms of the residuals. Now, in addition to histograms, we can also maybe do some QQ plots on this. Might become useful. So we can plot one column against another. So we are talking about the tough M thickness. So let's go tough M thickness included against tough M thickness difference. Let's see what that looks like. So here we get a nice QQ plot, and we can get a nice linear regression on this. Correlation coefficient of 0.98, slope of 0.97. So it does correlate well from that perspective, and there's a nice linear regression for the difference of I and D. You can also mess around with this a little bit, maybe the included versus the excluded. And that gives us a nice linear regression on that as well. Also, we can do scatter plots. So if we do kind of a similar thing here, we might take the tough thick included versus the tough M thick difference. And we can have, in our case, in this example, zeros here, so everything's kind of on the plus side. We do tough M thick excluded, apply, and we can see another scatter plot against that as well. So again, other additional information you get out of these residuals to help you make a decision on which interpolator to use. Okay, now that we have our histograms and scatter plots, we're going to close a few of these down. And go into maybe looking at a contour of these differences. Give us kind of a spatial view of where these differences are occurring. So we could do that under graphics, contour, and pick table as our data source. We have these residual tables. We want to pick our different interpolator residuals. So color X and color Y, and then we're going to pick the tough M thick D, which is the difference, and we're going to put that out to our design file called residuals that I've created, and then we're going to make this FEM tough MD, so we can differentiate that from our other interpolators. And then the contour, we're going to use rainbow, contour interval 0.1, annotation frequency of 5, no domains, no limits, no legends at this point. We could put in a legend. So let's put in, say, apply to that. And OK. And then we'll do this similar thing for each one of these. There's height. And we'll just change this out to be height. And then say apply. Write that. And then inverse distance. Just make this INV. And apply. OK. And then finally plan. And apply. OK. Now we could turn these and we will turn off our existing drill holes. So we can look at this, and then we will go to residuals. We have the FEMD, and that's our FEMD. So we can see we've got a lot of green here. This is kind of within a similar, if we hover over that, that's a 0.1. This lighter green is a 0.2. This blue here is a minus 0.1. This red here is a 0.5, so that's where our maximum occurs. And we can look at also, that's the FEM. Now let's look at height. And height doesn't have big swings like the FEM did, so it's pretty much a lot of green through here, which is 0.1 difference. This is a 0.2 difference, and this is a 0.5 difference here in this little spot, and then minus 0.1, and minus 0.1, and minus 0.3. Let's look at the inverse distance. Similar looking. it has a lot more variation in it across the area. And then planar. And it's not too bad. It does have some additional differences. So looking at this from a spatial perspective, maybe our height is not looking too bad from a consistency perspective. All right, this spatial information is pretty good, but we can maybe put some postings on there. So maybe we'll go ahead and post out of our residual table. So we'll take the, this is the height one. Let's go grab the height residual. In the X column is color X, color Y. The Z column is going to be our tough M thick D. And then we're going to post whole name and tough M thick D. We're going to send that to our residuals file. We're going to mark this up as height layer. And then we have some controls here. We can control how this gets posted. And then just say OK to that. I can continue to do that for each of the residual tables to get what I wanted. But let's turn on the height posting. And then we can get in here. We can see that this 0.05 is right in the X057 hole. So this might indicate in this space around here, from a exploration drilling perspective, you might want to poke a few infill holes here just to see what's going on here, maybe help that out a little bit in terms of why that one particular hole has so much impact on the interpolation. And this is the case for all interpolators as well, as we discovered. Now we might want to look at our structure contours for each of our intervals. So to do that, we might want to also create a grid model from that outside of a table model. So to do that, model geology grid, and we're just going to go down through each one of these. I got a grid spec available for that. We're not going to smooth the FEM, it's pretty smooth already. Hit apply, and then we're going to go to height, and not going to smooth that either. Hit apply. And we're creating these grids, inverse distance, I'm not going to smooth that either, apply, and then finally planar. And I am going to smooth planar because it has more of a triangular type interpolator, so I can smoothen out those hard lines that are in there. So that's done. So our models are completed, so let's go and create some contours of our model. Let's grab a hold of this FEM model. You can do a row fill down and pick and choose all the intervals that you want. I have listed here. I'm going to send this output out to FEM structure as an output design file. I'm going to be looking at thickness at a contour interval of 0.1, annotation of 5. So I'm going to grab the floor. I'm going to use a 1 meter contour interval and an annotation frequency of 5 on that. You can do some controls here. You can do rainbows, domain, limits, display. So I'm just going to go with that. So just say apply to that. And it's going to march down and give me my contours for that. While that's running, I'm also going to look at height. I liked height. I'm going to put this in my I created a design file called height structure. Same information there. Hit apply. Likewise, I'm going to do inverse distance. I'm going to put that in my inverse distance structure. All that stays the same. Apply. And then finally, planar. And I have a planar structure design file. All that's in there. Apply to that. So those are done. Let's go to my display, and I'm going to remove some of these, remove the residuals altogether. And I'm going to go to my Explorer. I'm going to go to FEM structure. I got this tough M thick. Let's see how it looks like in. And I can also maybe turn on my drill holes. So can see where that is. And this is the thickness contours for tough M. And then I could also maybe have a look at the floor as well. These are my floor contours for FEM. You can see they cut right through the drill holes at the floor of the tough M. And so that's the FEM. Let's look at height. What's our height tough M thick look like? A little different. Looks pretty good. You can see what those contours look like, and they might fit the bill. Let's look at inverse distance. Tough M thick. Again, that's another reasonable looking contour. And let's look at planar. Thick. Let's turn off inverse. So that looks not to be too bad either. So again, use your geologic judgment. Which of these looks best for you, or which makes sense to you. But more tools to help you determine what interpolator to use for either thickness or surface modeling. Well, thank you for watching this video on residuals in MineScape Stratmodel. Hope you find this informative. If you have any questions, please see our website. Have a great day.